Okay, for this lesson, we are looking at how to basically look at algebraic fractions. So for algebraic fractions, right, basically they are the same idea as numerical fractions. And fractions, remember, are of the form a over b, where a and b are integers, and b has to be non-zero. Okay, so the reason why is it b has to be non-zero is that if you put b as 0, then you have basically a divided by 0. Okay, so if you cannot divide by 0, right? If you put it to the calculator, basically it's undefined. So your denominator, or we cannot divide by 0, as you recall from what you learned in numbers. Okay, so examples of numerical fractions like 3 over 5, 12 over 7, and negative 5 over 8. So those are numerical fractions. So in this section, we will look at algebraic fractions. So what are algebraic fractions? Algebraic fractions are fractions, where the a and b, your numerator and denominator, they are what we call algebraic expression. Okay, they are algebraic expression. So example is like 2y over 5, 16 over 4h plus k, and so on and so forth. Okay, so you can see the difference over here. The rules for performing operations, they are the same as numerical fractions. Okay, what do I mean? So if you look at a fraction, the idea is that when you have a fraction, you want to simplify it into the so-called the simplest form, right? So when we talk about simplifying, it means that the numerator and denominator should not have any common factors. Okay, so as per what you do for numbers, right? Okay, fractions, numerical fraction a over b. If you multiply the top and bottom by the same number, generally the value of the fraction remains unchanged, right? So for example, if you take say a 1 over 2 and you multiply by 2 over 2, right? So if you can see that you have 2 over 4. So because 1 times 2 is 2, 2 times 2 is 4, and your numerator and denominator, they are the same thing. Okay, and when they're multiplied by the same number, you do see that the value of your fraction actually remains unchanged. Okay, so what next? The idea is also that if you divide by the same number, right? If you take 2 divide by 2, if you take 2 over 4, divide by 2 at the top and divide by 2 at the bottom, you will get like 1 over 2. And you also see that the fractions, the values remain unchanged. Okay, the values, they remain unchanged. They do not change. Okay, so it goes something like that. So the idea is that we're going to use this in the later sections here. So how do we simplify an algebraic fraction? So if you want to simplify a numerical fraction, the idea is very easy. We have like, for example, 4 over 6. You know that you need to so-called divide by 2 and divide by 2, and you get 2 over 3. So how do you know that? It's because you look at 2, you know that 2, you basically eliminate common factors from the top and bottom. Okay, so the idea is we are eliminating common factors from the numerator and denominator in order to ensure that this is in the simplest form. Okay, so a fraction in the simplest form basically means that there are no more common factors in between the numerator and the denominator. Okay, so when we look at this question, how do we determine what the common factors? So of course, if we look at algebraic fractions, algebraic expressions at the numerator and denominator, it will mean that you need to factorize. You will have to factorize your numerator and denominator in order to cancel out common factors between the top and the bottom. Okay, so let me give you an example. Let's look at this question here. Now we are asked to simplify 3xy cubed, 9x power 4, y squared. So this question looks, like unsimplified, right? So how do we simplify a fraction like this? So you agree with me that when we talk about terms here, this 3xy cubed, this is the same as 3 multiplied by x multiplied by y cubed. And your denominator basically is like 9 multiplied by x power 4 multiplied by y power 2. Okay, so when we want to simplify this fraction, we need to ensure that we cancel out common factors from the top and from the bottom. Okay, so if you look at 3 and 9, you can see that I can cancel out a 3 from top and bottom, and 3 divided by 3 gives me 1, 9 divided by 3 gives me 3. Okay, so this essentially here, if you look at this section over here, 3 and 9, I divide both by 3. Okay? And x power 1 and x power 4, right? I divide both the top and bottom by x because x is seen as a common factor. Remember that if I just pull out this portion for you, right? This portion for you, let's say if I talk about x, this is like x, and the denominator is like x multiplied by x, multiplied by x, multiplied by x. So if I cancel, right, it already looks something like that. It's like 1 over x cubed. That's why you can see that I am left with an x cubed. Okay, I'm left with an x cubed. Okay, if you are not very clear with this, just imagine if I take 2 times 2 times 2 times 2. Now, if I cancel this out, what am I left with? I'm left with 1 over 2 power 3, right? Because 2 multiplied by itself 3 times. So in the same context, we are looking at x cubed. Y power 3, y power 2. Now, if I cancel this, I'm left with y power 1. Okay, huh? So the division of y cubed, basically I divide by y square. Both of them I divide by y square. So this one is like, you see, I cancel y cubed. Again, if I were to pull out this section here, you can see that y power 3, this is like y multiplied by y multiplied by y. Y power 2, this is like y multiplied by y. Okay, so if I cancel, you can see that I'm left with a y power 1 in the numerator. Okay, so once I have my final answer, you can see that my final answer has no more common factors between the top and bottom. And this is my fraction in the most simplified form. Okay, and yeah, so that's what it looks like. Okay, now how about this question, 28 x cubed? So again, let me show you an example here. You can see that when I compare 28 x cubed, x plus y squared, 63x y squared, x plus y power 4. Now I look at the numerator, 28, 63. I identify that if I just look at this fraction, right, there are common factors between the top and bottom. So what I did is I divide both top and bottom by 7. Okay, you can see that here. Let me just highlight in red color. Okay, you can see that both top and bottom, right? The division is by 7. Okay, and I get a 4 and a 9. Now, x power 3, x power 1, the division is by x power 2 on both top and bottom. So if I take x3 and x, right, you can see that I so-called divide by x power 1, divide by x power 1, and I get x power 2 and x power 1 here. I just left with 1. So you can see that the one in blue, I'm left with x squared. Okay, y squared, now no one is divided by y squared, so y squared is alone. Y squared remains as y squared, right? Now, x plus y power 2, x plus y power 4, right? So when we divide this, we basically, let me just pull it out in yellow, right? If I have x plus y to the power of 2, x plus y power 4, now I just divide by x plus y power 2, top and bottom. You can see that the numerator becomes 1, the denominator becomes x plus y power 2. Okay, so this is just a factor where I mean with x plus y squared. And that's how I ensure that my answer is in the simplest form, where there are no more numerator between the, no more common factor between the top and the bottom. Okay, this is one example. Can I? So in this case, it's quite nice because the fraction is already like the numerator and denominator is already simplified for us. But sometimes, right, not every fraction is simplified. So let's look at the next example. You see this in page 133 of your 2A textbook. Okay. Now, if you look at this example, a squared plus 4ab squared, you can see that it is not factorized. So what they do here is they actually factorize the numerator. They extract the common factor a, and they basically divide both the numerator and denominator by a. Okay. So after we do that, right, you can see that the top and bottom have no more common factors. For 3t, t squared minus 2t, they also factorize the denominator, right? And they extract the common t factor t from top and bottom to give you the answer in the simplest form. For x squared minus 3x and 3x minus 9, we also factorize both the top and bottom. You get x over 3, okay, by cancelling out x minus 3, x minus 3. Okay, also this is how you can make sure that your answer is in the simplest form by extracting common factors and cancelling them out. Okay, yep. Okay, thank you.